Okay, 1-1. All right, statistics. What is it?
Taking stats.
Taking stats. Statistics. It's the science of collecting, organizing, analyzing, and interpreting data. You bring a bunch of data in, what does it tell you? So, you can major just in statistics.
No, that's sort of all statistics are made of.
Well, I don't know about that.
Oh, I just made that one up.
Oh, I was going to say, organizing.
Wait, is this then how you teach us how to gamble?
We can look. We're going to be looking at gambling at some point. Yes.
Are we going to play that game that the calculus students play?
Analyzing.
We're not on their level.
Yeah. I was. I already played it with them.
Cool. If we
Big bang.
should leave.
Yeah,
Maybe-
get out of class. Don't want you anymore.
Maybe I'm just going to come here and
You come in and support me.
Good, because what I'm going to do. What actually depends on what you think of.
Okay. Statistics can be used on a very simple, basic level, all the way to some super complex things. Okay, so the data sets that you collect, like the basketball coach might look at all kinds of stats, like I don't even know, what would you look at? Steals,
Volleyball coach, look at our steals.
free throws, especially any area, and then he gathers it all and sees where his weakness is at, and that's what that coach is going to focus on at a very basic level. Where's your team strong? Where's your team weak? This is what we practice on. So, now data sets. So you got to get all this data. I got to straighten this out. Okay, your data set. So where do you get your data from? There's two areas you can get your data from. You can get data sets from a population or a sample. A population is the collection of all outcomes. The collection of all outcomes, responses, or counts.
Gemini.
Let's say I was going to do a study on, I want to compare, maybe not compare, I just want to do a study on average backpack weight of the high school student in the United States. That's my study. See how I've defined what I'm looking at? High school students in the United States. So if I'm going to do the entire population, that means I would have to get to every single high school student in the United States and weigh their backpack. Is that something I could physically do myself?
Yes. No.
Every single high school student in the United States. I could get that piece of data.
No.
That seems a little enormous to me. Yes. So because I've defined that population as high school students in the United States, I've just made myself a data set that's impossible for me to get to every single one of them. But if I could, that would be considered the population data set, because I've gotten to every single high school student in the United States. But if your population is too large, which most times they are, you do sampling. A sample, not sampling, sample, a sample is just a subset of the population.
So you just do our school.
I could use our school, and I would still have to get to every single student here, which is still a lot of data to gather, but yes, I could use our school as a subset.
Is it sample, not sampling then?
Just sample, yeah. Population versus sample. A subset of a population. Well, then maybe I want to change my study. Maybe my population, I'm going to define, I just want to know what the average backpack weight here is at Gladstone High School. So now I've established just Gladstone High School as my population. I don't care what anybody else is doing, just here. And even here, if I don't want to do every single student, what do we have, about 500 kids? Maybe I don't want to weigh 500 backpacks. Maybe I take 20 freshmen, 20 sophomores, 20 juniors, and use those 80 people as my sample. So it all depends how big your population is, whether you're going to get to all those data pieces or not. So let's see, we're up to our first example. And on the examples, I just take them from the book. I don't always write them out. Oh, my book is taped together. Nice. Wonder what brat did that last year.
How many examples are we doing?
I don't know. Sample. Just sample. So our first example. Okay, here it is. The U.S. Department of Energy conducts weekly surveys of 800 gasolines. You hear this statistic all the time. The average price of a gallon of gas, you hear it on the radio all the time. Okay? This Department of Energy samples 800 gas stations to determine the average price per gallon. Take a look at how old this data is. On July 10th, 1998, were you guys born? Tell me you were born. Okay.
Yes.
That's good.
Exactly almost a year.
Okay. The average price was $1.66 per gallon. Identify the population in the sample. So, we survey 800 U.S. gas stations. For the price per gallon. Price per gallon of gas. That's what they're gathering. Okay. Identify who the population is or what the population is, and identify the sample used. So what's my population?
Gas station.
Where?
U.S.
How many of them?
800.
Nope. What's my population that I'm studying? All U.S. gas stations.
Oh, okay.
All of them is the population. Again, that's probably way too many to survey.
And the sample would be the 800?
And the sample would be the 800 pieces of data, the 800 stations that they actually used. All U.S. gas stations. Again, probably way too many to get, so they use a sample of the 800 that were surveyed. And what does the data set consist of? What's in their data set? What did they gather? What did they ask each gas station? The price per gallon. How much are you charging per gallon? So the data set would be this price per gallon. And they had 800 pieces of data, and they averaged them probably to give you the average price per gallon. Does that make sense?
Mm-hmm.
Okay. Okay, next one. 2 more definitions. We've got parameter versus statistic. Parameter. A parameter is a numerical description from a population data set where a statistic is a numerical description.
Oh, alright.
Well, I'm thinking that,
Yeah, you like actually said where is a statistic?
Yeah, I wrote that down.
Oh, sorry. Whereas versus a statistic, 2 different definitions, sorry, is a numerical description from a sample data set. And I'll talk about those two after you get them written down. Okay, if I go back to that very first example, just to talk about it, can I cover that up? All right. In that survey of the 800 gas stations, they said that the average price was $1.06 per 6. This description did that come from a sample or a population? A sample of the 800. So this $1.66 per gallon would be considered a statistic because it came from a sample of 800. If like my backpack one, if I do the entire, everybody in this high school, whatever that average I get, that would be a parameter value because I got to everybody. So it all depends on what you gather. If it's everything, what you're finding is a parameter. If it's from a sample, it's a statistic. Axel.
It's kind of not related, but
That's okay.
is that like 9/10 mean on the side of like
Actually, 9/10
of a penny? Is that what it means?
Yes. That's all just to make it look a little bit better than it is. Like, yeah, what is it?
219, 9/10 actually like 220.
Yes, exactly. It's essentially 220.
That makes me give gas so much.
Yeah. I know, doesn't it? So, the way you can remember this is a parameter comes from a population, whereas a statistic comes from a sample.
Whoa, did you plan that?
Oh, I just pointed it out. I didn't plan it. I didn't make this branch of mathematics. So our example here, I'm sure. Let's see. In 1997,
Can we not write that?
Major League Baseball, MLB, I'm going to shorten everything up. Major League Baseball team spent I don't even know what number this is yet, comma 119, comma 537, comma 215 dollars on players' salaries. Let's see what that number actually is. There's thousand, million, billion, 1,119,537,215 on players' salaries. Is this number right here that they're giving me, it's a total. It's not an average, it's a total. Is that going to be considered a parameter value or a statistic value?
Parameter.
Why is it a parameter?
Because they gathered
All the players. They added everybody's salary together and they're just giving me a total. They're not giving me an average per player or anything. But even if they had given me an average per player, that still would have been a parameter value because they used every single player's salary in their math. So this is a parameter. All right. That's all I wanted to be able to do there was pick out whether the outcome was a parameter or a statistic. All right, I think I have 2 more definitions and it's all. It's a good day. Okay, we have 2 branches of statistics. We're going to do the descriptive part of statistics in chapters 1 and 2, and then the inferential part's coming later. So the first branch is the descriptive. This involves the organization, summary, and display of the data, The second branch is the inferential branch. This is where we make conclusions. About a population. Based on the sample.
Are there only 2 branches?
Yep.
Will you make a little bit?
Yep. And I have my last example that goes with this. I thought there was. But. Nice, easy day to start with. This first chapter, it's only 3 sections long, and like I said, it's all vocabulary. We're just going to have a little 25-point multiple choice quiz on this first chapter at the end of the week here. Yeah. Yeah. And then chapter 2 actually starts making graphs and doing some math, and this first chapter is just kind of an intro.
Is this like one and
Yeah, and I would say if you were to take this class in stats, they'd probably cover this first chapter in one day. They'd go through all this vocabulary in one day and get it out of the way. But we're in high school, so we take our time. All right, you ready for the last example? What do you do, Michaela? Wait till I'm all done before you start?
Does that say? I forget that I'm writing. Can you move it over so I can see?
Oh, yep. All right, skip this little bitty in here. Here we go, example 3. Let's see, a survey conducted among of 1,017 men and men and women, total of men and women. Right there. Conducted by Opinion Research Corporation. A lot of the data you're going to see in the book was real data. It's just, 18 years old almost, for God's sake. But it's real data. By the Opinion Research Corporation found that 76% of women.
Wait a second. Why are you writing it that way?
Because I didn't want to run into this.
No, I mean, the men.
Okay. And 60% of men had a physical exam in the previous year.
Like a lot of words after this.
No. So we did a survey of 1,017 men and women, we don't know how many of each kind, found that 76% of women and 60% of men had a physical done in the previous year. Okay, first of all, these 2 percentages that came out, would those be statistics or parameters? Why would those be statistics?
Of the population, of the
Yeah.
sample.
We know there are more than 1,017 men and women on this earth. So this is definitely a sample, kind of large sample, but it's a sample. So these would be statistics. All right, got that out of the way. I want you to be able to tell me what's the descriptive part of this. The descriptive part is the actual, what did they find?
that only 76%.
Yep. Those percentages are the descriptive part. They gathered the data, they've crunched some numbers, these are the percentages we got. The 76% and the 60% is the descriptive part. What inferences can you make? Or what inference? Give me one.
Like a conclusion?
Yeah, what does this tell me?
So like, women are more likely to get a physical examination within a year.
Exactly. That's all I can say right now is that more women tend to have a physical exam than men. It's a good inference you made. More women tend to have physicals. So who would use something like this?
Doctor.
Yep. Physicals. They would probably, it'd say, they want to spend some money on some advertising. They want to get more business in. Maybe they put some money into TV ads that encourage men to come in to get your physicals done because they're the ones that aren't doing it. So that would bring more business into them. Yeah. Throw something out there, scare them, get them to come in because you know they're not coming in. So that's who might use something like that. All right. Your assignment. And don't think these are long assignments because they're just little one-word answers. Oh, you get to do, I can't find my white book because I'm just so organized up here.
Also, we don't have any. You don't need to find it.
White book, jump out and find me. Oh, here it is. Monday, stats, page 6. 1 through 24. Skip 11 and 13.